whatever we have done so far, like the laws, to see if we have understood them well, because the best way to judge if we can apply the formulas and our theories is to do the problems and see if we can apply them under varied situations. So a few examples on addition and subtraction. Let's start with the first problem here. This is the first question for us that's coming. Let's see what it is telling. This is the first question, and the question I just introduced to you. So here I have to do a light editing, but first of all let's read the question. Says in the figure, a figure is there also waiting for us. I'll just draw the figure also and bring it at the right time. Yes, this is the figure. In figure, the sides, well, I have to name them. This is, they are saying this point is A, this point is B, and this is my C and this is my D. A, B, C, D is a parallelogram you can see here. Also, the AB, this arrow represents a vector, B vector, and the arrow AD, this one is representing the vector A. Okay, so A and B are two vectors represented by the adjacent sides AD and AB of a parallelogram that is named ABCD. And this is the figure they are referring to in the question. The sides AD and AB of the parallelogram represent the vectors. Well, I have to write notations here. A very light editing. AD, this is an arrow, and AB, this is an arrow, represent vectors A and B. In printed material, you know that they use bold letters and A and B. And since I'm writing with my hand, I must put the small tiny arrows on top of A and B to mean that A and B are vectors. Then what are the vectors represented by the following? And each of them will have an arrow on top of that. The DC, CB, AC and BD, as you can see from the figure, they are asking, they must represent either a single vector or their combination in some way, plus or minus, and that is our task to do using whatever you have learnt about vector addition and subtraction. So let's start with the first part of the problem. Well, the part A, they are asking about what does the line DC, this arrow DC, represent? Now that's rather an easy job, because you can see in a parallelogram, I have said it before, that opposite sides have the same length and they are parallel to each other. So I could say that AB and DC have the same length and they are parallel. Similarly, AD and BC, they have same length and they are parallel. That's parallelogram's properties. So when they ask you about DC, you can say that the length DC and the length AB, they are definitely equal, and as well as the line DC is parallel to the line AB. So this DC vector, this vector arrow and the AB vector arrow, they are parallel and they have the same length. And I have said before, two vectors are said to be equal if they have the same length, they have same or parallel lines of support, and they have the same sense. So since DC from left to right and A to AB, that is from A towards B, they have same sense, they are parallel and they have the same length, we can conclude very safely that the DC vector is same as the AB vector, and both of them represent the same vector, that is B. Now that is the first part of the question. Well, it's a cakewalk, to be very honest. It's a very simple problem. First part, right? In my next part, they're asking about the vector CB. Just have a look. CB is from C towards B. So obviously we have to compare now this CB with AD, because AD has been given to be the vector A. So let me first argue from the visually here and I proceed to write after that. This AD and BC, well, I'm saying BC, not CB, they are equal and they are parallel. So BC must be A and CB being opposite to that must be minus A. In writing form, I can write down that the length AD and the length BC, they are equal because they are opposite sides of a parallelogram, AD and BC. I'm intentionally writing this. I just take them in the same sense. Also, you find out the AD vector and the BC vector, they are parallel, they have the same sense, A towards D, B towards C. So we could write down, this means the BC vector, that must be equal to the AD vector. Since they have the same length and they are parallel, we can shift vectors in case of free vectors, and AD being the vector A, of course BC is equal to vector A. But then you can see with the asking about CB, now CB and BC, the sense is changing. B to C is from here to here, and C to B is reversal. So they're asking for CB. Now this CB, can easily see that CB is nothing but minus of BC, because we have been changing or reversing the direction. So CB is coming out to be simply minus A vector. That is my answer of second part. We have seen CB is representing the vector minus A here. In part C, of course, AC, there is nothing to comment because that is the law you have already learned. In a parallelogram, if AB and AD represent vectors B and A, the diagonal passing through the common tail represent their resultant or vector sum. So even applying the addition law of parallelogram straight away, we could write down that the AC, the diagonal passing through common tail A, represents the summation of AD plus AB, of course vectorially, and that is simply the vector A plus vector B. So the vector sum is given by the arrow AC. Now that is the third part, and let me highlight as usual. I'm doing this. This is the third part's answer. We go to the fourth and last part of the problem now. In the fourth part of the question, they have asked what does the arrow BD represent. Now for this, I shall take recourse to the triangle law rather than parallelogram law. Although it's a parallelogram, I shall just see that in the triangle ABD, let me write in the triangle ABD, you can see that AB, the vector, the side rather AB, and then the next side BD, they are taken both in the same order. Same order means I said that first one's head coincides with next one's tail. So AB plus BD, the third side in reverse order. That's triangle law. The summation of two vectors represented by two sides of a triangle taken in the same order is given by the third side of the triangle taken in the reverse order. So you could write down AB plus BD, as you can see in the triangle ABD here, AB plus BD is coming out to be AD. And this means we just separate out BD. That was the question. The vector BD is given by AD, just rearrangement, changing of sides, and then I took AB that side minus AB. Now since AD has been known to be vector A, small a, that is small letter, and vector AB has been known to be vector B, the answer follows in a jiffy, is coming out to be simply the vector A minus vector B. So BD represents the difference of the vectors A and B, and that is the answer of the fourth part of the question. This is vector A minus vector B. That is what this line BD arrow represents. So these are the four parts of the question that gives a little insight into the application of addition laws as we have seen here. So I have taken a little pain to write our findings on the figure itself. DC is the vector B, then CB was the vector minus A, AC, this diagonal is the vector A plus B, and the diagonal BD is the vector A minus B. That's on the screen, that's on our figure. Now let us go for a second example on addition and subtraction of vectors, and this will be the question number 2 for us in this session. What does the question say? Refer to the figure. Well, there is a figure here and I introduce the figure on the screen. Now in
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.